All right, so this is the second presentation about lean. As promised in my previous presentation, it's about Lean Six Sigma. So we're going to learn a little bit about Six Sigma here. Six Sigma is a quality improvement process, and it works very well with lean because Six Sigma is about the idea that you continually improve. You never stop. You're never good enough. You always keep improving. And lean is about that same sort of thing. Six Sigma is a specific methodology for tracking quality within lean. So General Dynamics decided to do this presentation. They put it out for public release. So we're going to learn about what is Lean Six Sigma, what can it do, and they want to talk about how it got to get started. We're not going to talk about how to get started. We want to learn this because we know that Six Sigma presentation and Six Sigma metrics, I know this, and you eventually will know this, is important for any success for projects that we move forward on. So cost reduction. Lean and Six Sigma, in the end, is about cost reduction or quality improvement, which in the end helps your customers and in the end helps make more money. So it's all about making money. So there's two approaches to it. You can cut services, you can reduce labor, you can contract work out, you could do all these bad things, or, and I show you a boat there with nobody in it, or number two, you can surge forward with a lovely boat in a sail and remove roadblocks, assign resources to bottlenecks, minimize or maximize your internal capabilities and focus on what the customer wants to buy. So that's sort of the idea here. So what is Lean Six Sigma? It takes lean and combines it together and gives you this set of tools. We've seen a lot of these tools already. We've already talked about some of them to ad nauseum. Kanban, Kaizen, 5S value streams are the key ones that we're going to be using. And JIT is also useful. And we'll talk about how that might be used in, it's just-in-time pull-based, might be used in a manufacturing line, like a robot system as well. Other ones are more sort of business improvement-y things. We're not going to use those, but they're useful to learn about. The focus with lean is value to the customer. We've already talked about that. We're going to map the actions required to produce that value stream, and we're going to eliminate activities that don't produce value. So this is where I like this slide set. General Dynamics says, which ticket do you want? All right, you want that ticket with a $500 round trip, but it takes 6 hours and has 3 layovers. That doesn't sound like a great process. But you're arriving in New York City. Is that more valuable? It's a cheaper ticket than the one that has 3 hours, 1 layover, and you'll arrive right where you want to go, Groton, New London. So which is more valuable to you? Is it more valuable to you to save that $150 or to save that 6 hours of total flight time and 2 extra layovers? I think for me, if I'm a business customer and can spend that extra $150, I'm definitely going to get ticket B. And that ticket B is where you want to be. Hopefully not the $650, but where you want to be in your manufacturing line. Less layovers and less total time. So this slide set focuses on value a lot. You know, it's more than just cost. It's timing, it's quality. It could be expressed in any number of things that are important to the customer. So it's one of the important processes that we're going to learn as we develop work cells and as we develop manufacturing changes is learn how to listen to the customer. Now, here in the classroom, we don't have real customers. You're going to be given different kind of examples. I'll call them business cases, where you're going to have to pick out what the word of the customer is and how to apply it for your new work cell. And once again, we're going to talk about value added and non-value added activities. Here are the 8 types of waste we saw earlier. Actually, I don't think it's exactly the same number, but they give you some great icons here to understand what those types of waste are: weighting, correction, conveyance, motion, overproduction, overprocessing, extra inventory, and underutilized skills. I like underutilized skills. It's the best waste. And here's an example of something they did at Electric Boat, where they had a valve block where they had to basically add legs and feet to this block to get it machined properly and lifted properly. So what they did is they redesigned it with legs and feet built into the basic design of it. So it did not need any kind of temporary attachments. That's an example of lean. They took away all these steps of adding and removing temporary attachments, even if it made a slightly heavier and clunkier looking valve body. Another lean example is the idea that they were producing certification packages at Electric Boat. And these certification packages were things that they knew they had to do. They started in 1941, whenever they started producing these submarines. And the Army or Navy or whoever was, I guess it had to be the Navy, was using these submarines, required a certification package for each component. And then somewhere in the 90s, they said, we don't need that. It'll come electronic. And then somewhere in the early thousands, they said, we don't need that. All of that's electronics. You guys are so reliable. We don't need a certification. On this, this, and this, all we need is just this. So to get to lean, you go back to your customer and say, do you still need this entire package? The answer is no, we don't need that package. A lot of it's not required. We don't need a redundant review. And you can take out the places where you had to recheck things. No more rework. Because those are examples of improvements that Electric Boat did. Another improvement that's constant for lean manufacturing is, instead of having multiple processes with queued up inventory, I like the fact that their queued up inventory are little pictures of submarines. I'm kind of laughing at the concept of a little flock of submarines stacked up between work cells. But yeah, it takes, in this example, 30 minutes for an order of 10. And if you put them all in the same work cell, ABC, in 12 minutes, you can produce an order of 10. So you can reduce your cycle time. In this mini pictures of submarine example, with a continuous flow, a lot better process. Also, by moving your work cell together to one place from multiple departments, having multiple different sets of machines or processing, you can create a continuous flow and radically reduce walk time and overall time to produce. So this is a typical manufacturing line before they apply lean. The green blocks are time where they're actually doing something value added to the customer. Those sort of gray blocks are areas where it's not value added time. It's transportation time, wait time, setup time, wait time, transportation time. And here's an example of a value stream map laid out for Electric Boat. Actually, I think it's generic, not Electric Boat. Somebody else wrote this. I'm not going to go through that. But the result of that value stream map is the total lead time is 48 days. 48 days to produce this product. But the part that's only value added to the customer was 315 seconds. So basically, what is that? 5 minutes or 6 minutes worth of time? So the lean approach is to focus on making all this visible, make all your value streams visible to everybody involved so that everybody can be on board with the improvements that need to happen. And they're saying the traditional approach is to buy better tools and machines and that sort of thing. And the better way is to focus on improvement by removing non-value added time. And they say continuous flow is better. I'm going to skip over that slide because that's sort of obvious. The main value of lean is focusing on what the customer sees as valuable. Understand their expectations, and just going back to your customer on all the different parts that you're producing will create value for your business. So now we're going to get to the part that the Six Sigma part out of General Dynamics. The idea of Six Sigma is you've got a measurement system. That measurement system measures quality. So Six Sigma basically is a change in how you measure quality. In the old days, you had an upper limit and a lower limit. And if it was lower than that, like your size for your part you just cut was too small, it would fail. If your size for your part was too big, it would fail. And that range, anything in that range is okay. But that's not good enough for Six Sigma. What you want to do is create a model where you're not creating parts that are at the outside edge of that range. You're continually improving that part because that deviation from target causes an increasing number of problems. And so by continually improving your process, you get rid of that small variation, which saves you money. And by continually improving, you define, measure, you analyze, you improve, and then you control. You're continually making your products better. Here's an example that they talked about for their technician exams. I'm not sure how appropriate it is for us, but so their technician exam pass rate was declining, and they looked at it and said, well, why aren't our technicians passing this exam? So they dove into it. They looked at the formula for creating scores, and they looked at the place of training, the exam selection, how skills were used, the elapsed time between the training and the exam. And they discovered that 3 sections of the exam were causing the biggest set of problems. And that the ones that passed this exam were the ones with the most experience. So what they did, instead of changing the exam, they focused their training on those 3 areas for their inexperienced technicians. They gave them more experience. So that's an example of how you would deal with the Six Sigma. So Six Sigma talks about a percentage based on a normal bell curve for how often a particular occurrence, how often some sort of event occurs. A bell curve is just a way of describing a normal distribution of events. Say if you're cutting parts off and you chop those parts, you'll see that they aren't precisely right on target each time. Some of them might be a little bit short, some of them might be a little bit long, and the longer ones tend to be less common, so there's less of them, so they're down on that right side of the bell curve, and the shorter ones are less common too, so they're on the left side of the bell curve. The sigma means standard deviation. It is a way of measuring how often that occurrence occurs. If you say Six Sigma, that means that that's an event that occurs only at 6 standard deviations out. That means it occurs only 99.9999% of the time. 1 minus that. So just a tiny, tiny fraction of the time that event could occur. So that you want to prove that all of your products are staying at that high percent of good. And this is the slide that says, is Six Sigma too much? Is that 99.99% good? Too good? Is that overkill? And they compare 20,000 articles of mail per hour. If we didn't have Six Sigma and we were mailmen, we'd be in trouble. But if we do match Six Sigma, there's only 7 lost articles of mail per hour. Actually, I'm not sure. We probably have more than that. If we had not Six Sigma, 1 Sigma, then we would have 15 minutes of unsafe drinking water every day. So I think they're being a little bit over the top with this presentation. And they talk about one of their examples where they started doing some pipe welding. And they did some effluent discharge, and then they went ahead and did some value stream mapping. And they talked about ways to get to Six Sigma, identify critical inputs and control them, quantifiable management. You have to have a measurement for your performance. That's really, really important. We're going to talk about that methods later. And they talked about their methods to get to Six Sigma. Which I'm not sure is important for us. All right, the important stuff for us is to say that Six Sigma is a continuous improvement methodology for statistically how you produce your product. From a robot work cell standpoint, Six Sigma is important in terms of robot movement. If I can get that robot to pick up the part and place that part properly 99.99996% of the time, then we're good. If I get it so it's only 99% of the time, that's not good enough. You want that robot to work continuously for days on end. You don't want to have to get back in there and tweak the part. The example I'm giving you is based on a real world example at Pella. They've got a robot cell there that screws up just often enough to make it so they don't want to run that work cell until someone's fixed the problem. So you don't want to be that guy to make a work cell that's only 99% good. All right.